Okay, yeah. Is it visible to everyone?
Yes, sir.
Yes,
Okay,
sir.
thank you. Yeah. So, so today we have to discuss about one of the more fundamental aspect for research paper. So yesterday we had talked about all the technicalities in terms of research paper writing. So first of all, we had and tried to understand, how to write a research paper with the starting point of the meaning of research paper, and then gradually we have moved on to have the various steps and things that we have to take into consideration as a part of research paper drafting, right? So now I think the things are clear to all of you as far as research paper writings, because we had a lot of discussion yesterday for 1.5 hours. But still, if anyone is having any doubts, you can ask me, right? So with this part, we have to now understand application of data analysis tools and techniques. So this is one of the crux of research, because whatsoever things that we understand, in terms of the technicalities, in terms of the parameters, and all such things, which is the part and portion of the research paper, right? But ultimately we have to try to understand how much and how the data will be applicable in different scenarios, because it is very very important, you know for the yesterday session also, that if it talks about data collection, so data collection needs to be done. So you do not have the backward option as far as your research journey is concerned, because usually people don't want to answer your questions in a multiple times, or you are going for the second times by considering that the first attempt that you have made for the data collection was wrongly appeared, because people are not having any times and people are not interested much, in a sense that we go to the market and asking for the data in terms of giving them the questionnaire and we are asking them for the responses. So it's a quite tough job. So that's why it is a tough job. That's why we have to make very keen approach, very sensitive approach in terms of drafting your questionnaire. So when we are drafting a questionnaire, we must have to think well in advance that which sort of data analysis tools and techniques that we want to apply. Again, the answer lies in the yesterday session only, because if we are deciding that this particular data analysis tools and techniques that I need to apply, it usually comes with the sentiments of systematic literature review that we have done it, because every genre, every data, every types of questions that we are asking, we should not apply every data analysis tools and techniques on every type of data. So every data has certain behavior, and every application of data analysis tools and techniques have certain characteristics to give you the answers in terms of the research questions or research problem that you are looking for. So which sort of data analysis tools and techniques that you are looking for, with the consideration of the objective. And objective obviously comes from the systematic literature review. So again, as I already told you yesterday, that everything is synchronized process. At no point of time you can list out those things. So if somebody is thinking that, if I'm doing research work, firstly I'll do literature, I'll do research problem, I'll make a questionnaire, whatever I feel it, irrespective of the scientific looks of, which sort of questions I need it, which type of questions are I need it, and which questions I need it. So sometimes you are making mistakes, because the way, the place where you want to live, the place where you want to go, somehow you are missing the train, right? So that is very very important, that all the rough work, all the groundwork that you are looking for your data analysis should be done at the time of drafting a questions, right? Then after, you cannot have the reverse pattern, right? It is irrevocable decisions in terms of the types of questions that you have asked, to the respondent. So very vigilant approach is needed in terms of this kind of approach. So what we have to do is, type of data we have to understand. And yesterday also we had a glimpse of the types of data, which is the art of the social science research, right? But so this, with this note, I'm starting my presentation, that today we are going to see the application of data analysis tools and techniques. Okay. So types of data in research, nominal, ordinal, and scale data. So I hope the meaning is clear to all of you. Yes or no? Right. So nominal, ordinal, and all these data that we have to see. So nominal scale data we have already discussed yesterday. The age, you have to forget about it. So we had talked about gender. So gender in terms of we have two categories, male and female. Yes or no? So you first need to understand that whenever you are talking about nominal and ordinal scale data, so firstly we must need to see this. These are the categorical questions, right? That means whatsoever questions that you want to ask to the respondent in the research, it has to be converted and it has to be there in the categories, right? So here you are asking the questions in terms of various categories, right? So here you are designing the categories. So right now we have designed, and I have designed right now the gender in terms of male and female. Now the question and the difference point of nominal and ordinal scale always comes with the sequence of this particular category. So whenever we are asking this particular categories to the respondent to answer, we have to see this. Does this category means for the sequence? If yes, then you have to see that this sequence should be in order. That's why it is ordinal scale data. But if this categories does not require any sequence, then it is considered to be nominal scale data. I hope I'm making sense. Yes or no? Any questions?
Yes, sir.
Right. So under this, male and female does not require any sort of sequence, right? So sequence does not matters. So it is nominal. And when sequence does matters, it is ordinal, right? So this is nominal and ordinal scale data. So which type of questions you have to ask to the respondent in nominal scale and ordinal scale? Again, you have to decide well in advance before applying your data analysis tools and techniques and before finalizing your questionnaire. That is what I'm saying, that at which stage you have to make it final. So at this stage of designing of questionnaire, right? So this is where you have to be very vigilant in terms of deciding this part. Then interval, again, it is, the grading marks where, the difference of the categories, or you can say the range of the category is in equal categories, right? So this distance of each category should be equal, like 1 to 10, 11 to 20, 21 to 30, 31 to 40, right? So every interval, the difference of 10, right? So this is interval data. So usually the ordinal and interval data are almost, it is in the similar point. Ratio data is usually considered to be the scale data, just like yesterday we had discussed, right? That I can ask the age in two form, right? The first is up to 20 years, up to 20 years, 21 to 40 years, 41 to 60 years, and more than 60 years, right? So this is the categories, right? And this category needs the sequence, right? This category needs a sequence. So that is in order. So this is ordinal scale data. And again, this is not starting with the 0 point. That's why it is not interval data. Otherwise, it could be, right? Or it could be interval also, because it is starting from up to 20 years. So 0 years is also considered. But again, the respondents are not from the 0 years, right? So age usually fall in the ordinal scale, right? Usually the marks and all this part should be the part of interval. Again, it is a part of order, but this order also in equal distances and starting with 0 point, right? And ratio means, again, this age I can ask in the form of like this. I can make it as an open-ended question. So this is age. So here the respondent can answer 26, 48, 64. So this is pure numbers in which the respondent needs to answer. So this is a ratio, or you can say the scale data. Or in finance, those who are doing econometrics analysis, long time series analysis. So you have the stock prices, closing price, net profit, right? So on, so on. So this kind of data are considered to be the ratio or scale data, right? So this is how we have to take into consideration. So whatever data that you have it, first of all, you have to check the normality. Can anybody tell me why we are using normality test? Anyone is having an idea? Why we are using normality test? Any guess? So normality test, usually we are doing with Kolmogorov-Smirnov and Shapiro-Wilk. right? So this is called KS test, and this is called SW test, right? Usually the data should be followed normal distribution. So I hope you all have gone through this bell-shaped curve in your student life, or might be in academic journey as well, if not in student life. So this is bell-shaped curve, right? So this is called normal distribution, right? So every observations are on equal distribution. So data are considered to be normal, right? So when your data, that means your sample size here, which test you have two tests. One is Kolmogorov-Smirnov and second is Shapiro-Wilcoxon, right? So which test you have to apply for your data, it usually depends upon the sample size that you have it, right? So sample size could be either fall into small numbers or either it could be in large number, right? Now, what is the definition of small number and what is the definition of large number? So the definition of small number is less than or equal to 50, right? So if your sample size is up to 50, to check the normality, you can go for Shapiro-Wilcoxon. I hope it is clear, right? And if your sample size is greater than 50, then you have to go for Kolmogorov-Smirnov test. Is it clear? Fine. Okay. Then secondly, you have to discuss about the acceptance region. So this is true tell, right? So this is, this region is like this. It is a shaded region. So what is this shaded region? Is it an acceptance of null hypothesis or it is a rejection of null hypothesis? This shaded region is called the acceptance of null hypothesis or rejection of null hypothesis. Let's say we are taking significance level of 0.05% over here. So is it the acceptance or rejection region? What this 0.05% is called? Be interactive, right? Because this is a practical class. So you can share your knowledge because what you know based on which I can explain, or even if you are mistakes, so I can clarify. What this 0.05% is called? What is the difference between significance levels and confidence level? I'll give you one answer. We have two particular things, 95% and 5%. Can anybody tell me what is 95%? Is it significance level or confidence level?
It is confidence level.
Confidence level. Why it is called confidence level, madam?
It means that the proportion of times that we have expect an estimated range. That is why we get a likely confidence interval. That is 95%. To
Right,
contain the
because
two
we are
population
considering
parameters.
5% is a significance level, and significance level is considered to be error. Yes. So 5% would be the chances of error. So 95% we are confident that our result is correct. Right. That's why it is called confidence level, and 5% is called significance level, or chances of error. What I can say is, so this particular shaded region is called significant level, and this is called confidence level. Right. So this is significant level, and this is confidence level. So if your data, if your p-value is falling into this region, right? So what should be the interpretation? What is this called as? Does your p-value is greater than 0.05 or less than 0.05? If your p-value is falling into this region, it is less than, because if you go to number line, right, it starts from negative. So negative here, these values are higher. And whenever you reach up to this level, the numbers are going to be down. So if the 0.05% is ending here, and if the values are going still over here, right? So these values are less than 0.05. So if p-value is less than 0.05, p-value is less than 0.05, right? So what does it mean? Let's say your
The
p-value
null
is
hypothesis will be rejected.
null hypothesis would be rejected, means it is falling in the significance level, and significance level means it is called the rejection region of null hypothesis. Perfect. It is called rejection region of null hypothesis. And if your p-value is falling into this region, let's say you are getting p-value 0.100, right? So your p-value might be falling into this area. So this is called confidence level, or you can say the p-value is greater than 0.05 and it is not falling into rejection region. So if your p-value is greater than 0.05, right, you have to accept null hypothesis. And if you are rejecting null hypothesis, then what you are expecting, I'm expecting H1 to be accepted, right? But here you have acceptance of null hypothesis, right? So ultimately we have to reach to the conclusion that which hypothesis got accepted at which p-value. So if your p-value is less than 0.05, you have to accept alternate. And if your p-value is greater than 0.05, you have to accept null hypothesis, right? And simply you have to read the statement of the hypothesis, that null hypothesis is saying that the data are normally distributed. So when your data is going to be normally distributed, when your null is going to be accepted, when your null is going to be accepted, when your p is greater than 0.05. I hope it is clear. Understood? And when your data are not normally distributed, so when your alternate is going to be accepted, H1. So when H1 is going to be accepted based on p-value rejection criteria, so your H1 is going to be accepted when your p-value is less than 0.05. Is it clear to all of you? Fine enough. And you can check this p-value over here. So significance value is considered to be the p-value. And you can see this for all the statements that we have asked. The p-value is 0.000. Is it greater than or less than 0.05?
Less than.
Less than. So if it is less than, then which hypothesis got accepted?
H1.
H1. So your data are on in with this result. What can you interpret? Does your data normally distributed or not? If H1 is accepted, your data are normally distributed or not? Not, because H1 itself means that data are not normally distributed. So here in this case, all the data are not normally distributed. You can see this. Even you can see this Kolmogorov-Minro, and you can also see the Shapiro-Wilcoxon. Not much difference in both the results, irrespective of the sample size. Is it clear? Over here, we have a sample size of 153. So obviously, we have to go for Kolmogorov-Minro. But again, you can check this. The result is 0.000, which is less than 0.05 significance level. So obviously, right, your alternate is going to be accepted, and alternate says that data are not normally distributed. I hope it is clear to all of you. Any doubt in this? Anyone who has not understood anything, please ask. Clear with this part? Okay, let's see the live demonstration of this particular aspect. Okay. So this is one data file. As you can see this. This is one SPSS file, where we usually put the data. Just a minute. Yeah. So here you have seen this data. So usually normality can be checked on scale data. So this is a Likert scale data statement, right? So these are the various features which, usually the consumers are getting from the market, from various financial institutions like bank, or in some case it is NBFCs also. So whenever you have to do the normality test, you usually go to analyze, right? And so analyze function is very, very important for SPSS. to go for analysis perspective. So in analyze, you have to go to descriptive statistics, and in descriptive statistics, you can find out the frequency analysis, you can find out the descriptive statistics. And the third option is explore, where you can find out the normalities. Then fourth is crosstab. So this is a normal, crosstab and chi-square functions for the normal data distribution. Then you have PP plots and QQ plots, that is quartile and percentile. And even if you are looking for the ratio, so you can have the ratio. So frequency means the number of observations, in terms of the frequencies. And descriptive means, so measures of central tendencies like mean, standard deviations. So all sort of range, maximum value, minimum value, right? So all sort of things you can get it from the descriptive statistics. But here we are talking about the test of normalities that we have to apply. So test of normalities you are always finding in explore. So you have to click over here, explore, and under the explore, you have to click all the statements which you have asked in Likert scale as a part of scale data. So here you can see this scale data, right? So you can click each one observation by putting shift and down key. So you can see this much amount of statements which I have asked, right? Okay, so up to this, so I'll click and put on this side. You have to go to statistics. So descriptive statistics is already there, and you can see this confidence interval for mean. And you see this 95% just we have discussed on the slides, right? So 95% confidence means we are assuming that, and we are communicating to our readers that whatever analysis we have done, it almost 95% accurate in terms of the result generation. So that would be a chances of 5% that our results may be faulty. Continue. Plots. You can click on plots. Very, very important that you should put on this normality plot with test. So if you are looking for Kolmogorov-Monro and Shapiro-Wilcoxon test as a part of normality in terms of p-value receiving, you have to click on this portion compulsorily, right? Without which you cannot get the Kolmogorov-Monro and Shapiro-Wilcoxon test. Again, you can check the histogram as well. If you look forward for the histogram for each statement, to see the normality curve, in terms of the observations that we have received. So you can also check the visualization tools, and you can also decide that whether this data is normally distributed or not, apart from the values that we are receiving in terms of P. Then options, nothing to do. Bootstrap, nothing to do. Just click on OK, and it will generate the results. It takes time because normality is usually a huge responses. So it takes 1 minute. Okay, now the results is here. You can check the results. So firstly, we have to check the normality test. You can see this test result, right? Right. So in spite of understanding over here, let's take this result into Excel. It would be better to understand. So this is, numeric values through which you can decide your normality. Again, we have a data visualization part also in the same part. So after this, I'll also show you the data visualization part in terms of understanding. Okay. Now you can see this. Now you can see this results, right? So this is the results that we have it. So Kolmogorov-Monro. So you have to see this significant values, right? This significant value. So this is for when the sample size is high, it means more than 50. So here you can see this degree of freedom. So it is nothing but the sample size. So our sample size is 100. So obviously we have to go for this Kolmogorov mean row. So this is how we have to decide based on sample size, because our sample size is usually large. And you can see this significance value. So significance value is also considered to be the p value, right? So this is considered to be p value. Yeah. So here it is p value. So now what we have to see is we have to check these figures, each and every figures. So this figure is considered to be p value. So the formula for p value is, right? So when to accept null hypothesis and when to accept alternate hypothesis, right? So we have already discussed about this. We have already discussed these things. So H0, H0 and H1, right? So H0 is accepted. Can anybody tell me when H0 is accepted with the p-value rules?
Greater than 0.05.
Perfect. When p-value greater than 0.05 significance level, right? So here, what's your p-value? But okay, before that, let's see these rules also. So when alternate is accepted, when p-value is less than 0.05 significance level. So over here, if I'll put this same figure into downward, so you can make a comparison that what is your p-value over here. You can see this yellow line. Your p-value is 0.000. I don't know who is bigger one, but here also I'm typing 0.05 significance level. Now you tell me, out of these two figure, which one is bigger one? 0.000 or 0.005? Which one is bigger one? Which one is bigger one? 0.000 or 0.05 is bigger one? Come on, the difference is very clear.
0.05 is bigger.
0.05, right? So that is significance level. So p value is less. So you know the rule, when the higher value is there, the two arrows will be open in front of the higher number, right? So 0.05 is higher. So this two, window will open on that in front of them. So the p value is less. So they have to face the backside of this particular arrow. So this is normally considered to be less than, right? So because greater than and less than depends upon the first parameter that we are putting into comparison. So first parameter is p value. So here we can read this particular thing is p value is less than 0.05, right? So what is the meaning of it? If p value is less than 0.05, which hypothesis got accepted?
Alternate hypothesis.
Alternate is accepted. When what alternate says? Data are normal or data are not normal?
Not normally distributed.
Data are not normally distributed, right? So this is what the interpretation that we have to take up. Clear? So here your distribution is not normally distributed, right? So now again, we have to see that which test is applicable based on normality, right? So if data are normal and if data are not normal, right? So based on this scenario, we have to decide that which test is going to be applicable. So if data are not normal, then we usually apply parametric test. And if the data are not normal, then we usually apply non-parametric test. Clear? So based on normality, we have to apply this different test. So if data are normal and if data are not normal. So we usually apply parametric test, right? And if data are not normal, then we usually apply non-parametric test. I hope it is clear.
Can I
Yes,
ask one question, please? Yeah.
please.
So probably I missed the point where you were telling about the normality of the data. Uh,
Okay.
so when we are talking about data is normal, what do we mean by that?
Data normal means that all the data are within the range, right? So whatsoever data that you are collecting, right? So let's say you are getting some, average figures of that particular aspect, or let's say if you are taking some opinion of the people, so almost the people opinion are in the similarity range. But if there is a huge deviation in the, the opinion that you are taking, so usually the behavior of the data is not normal. That means it is beyond the expectations. So that is called data are not normally distributed, right? So somehow, what is the meaning of normality? So normality, usually we believe and we depend upon the results of the average value, right? So when the data are not behaving in a normal way, that means every from each and every observation that you are taking as a part of your data analysis, the data are behaving very abnormally, राइट जैसे कि लेट्स से एक इंसान जीता है तो उसका हार्ट बीट होता है तो एक नॉर्मल रेंज में वो बीट करता है बट इफ द हार्ट बीट्स आर गोइंग वेरी अप एंड वेरी डाउन so that is shows abnormal behavior. So whenever you are noticing this kind of abnormal behavior, so the treatment of this particular patient cannot be depend upon the average values of the heartbeat of the normal person. So that is where the average, measures of central tendency is not going to work out as a part of data analysis perspective. So in this case, we have to observe the behavior of this particular patient only, and we have to go for the mean rank of each and every patient of this abnormal behavior. So normality parametric test is also, usually working on and giving a judgment of the result based on measures of central tendency like mean and standard deviation. But non-parametric tests are taking the mean rank of the mean values. Is it clear?
Yeah. So this normality is also associated with data reliability, where we find out the Cronbach alpha.
No, data reliability is usually, we are checking the quality of the data that we have taken. So normality is, different. Data validity is a part of reliability. Your data is valid, that means does the respondent has understood your questions, so that is where reliability needs to be checked, Cronbach alpha. So every statement wise, you have to check the Cronbach alpha. Even you can check the Cronbach alpha with this every statements. We can find out the Cronbach alpha for all the statements together. But if you want to check that if you have missed out the Cronbach alpha with some minor values, and you want to see that where is a loophole on this particular aspect, so even you can get the Cronbach alpha for the every statement. So Cronbach alpha usually shows that, what is the understanding level, what is the market acceptance of the questions or the understanding that you are looking for as a part of your data.
Thank you.
Right. Any more questions? Clear to all of you?
Yes, sir.
Okay. Now you can see this normality test. You can also have the visualization aspect, right? So you can see this histogram as I already mentioned, right? So you can see this histogram, right? So if we copy this histogram in the Excel, right? Just you see this is a histogram of accessibility, right? So you can see this histogram of accessibility. You see the behavior of this data, right? It is not normally distributed. You can see this, it is upward line. There is no downfall over here, right? So this is not normally distributed. I think it is positively skewed. Why? Because if you can check this, the mean value is 4.1, right? So mean value is 4.1 means usually the respondent are in the categories of 4 and 5 scale, that is agree and strongly agree category. It is not equally distributed among all the observations, right? So they have the particular biased opinion towards certain categories, right? So this is not normally distributed. Clear? Okay. Then another category to check the normalities, steam and leaf plot, right? Then you have normal QQ plots. You can see this normal QQ plots over here. There is, the linear line that has been drawn in this particular aspect. But if you see this, there are certain observations which are going beyond the linear line, right? They are not falling into the, the average of the what is expected, right? So you can see this, the average is not meeting up by the majority of the responses, right? So that is why over here, to take the decision for any of the, of the observation or any of the hypothesis, it's not possible based on mean value, right? Because data are not behaving in the average range of the mean value, which is there in the linear line. So they are moving ups and downs, based on the expectations. So again, the behavior of this data is not normal, right? So that is where we have to see this. Then again, you can see this determined detented normal QQ plots. Again, you can see this. This is the normal baseline, and you can see the difference of the behavior of the data. They are very, deviated from the baseline, right? So again, it reflects that data is not normal. And box plot, you can see this. The box plot itself says that the observation should be within this box or within this line. But you can see this. The majority of the observations are beyond the box. So again, the box plot is also saying that data is not normally distributed, right? So this is how the normality function needs to be executed. Clear? Okay. Then, so based on this particular normality and non-normality, there are certain parametric, non-parametric tests that we have to see. So again, we have to understand this, the categories of the data. Just like we had discussed about the gender. So gender, we have bifurcated into two categories, male and female, right? So here we are discussing about how many groups of needs to be compared. So if I want to compare the variable gender, so gender is considered to be variable and male and female is considered to be the group. So here the point of discussion is, this is the group. So how many groups I need to compare to check the difference of opinion among the gender? So here I'm talking about discussing about two groups. One is male, another one is female, right? So again, I have to check all the data to be normally distributed or not. So let's say if I want to check the difference of opinion among the genders of the consumers, right, for having their opinion for the accessibility function for the online banking in Ahmedabad city of Gujarat state, right? So what I need to do is, I need to check the normality, and you have seen this normality value, accessibility. So normality data was not normally distributed, right? So here I need to answer the question that, data normally distributed. If yes, then your null hypothesis should be accepted. If no, then your alternate is going to be accepted. That means your data are not normally distributed. So if your data is normally distributed, you have to go for parametric test. And if your data are not normally distributed, you need to go for non-parametric test. But before going to this, I wanted to say one more aspect over here, right? So just a minute. Right. So this is, the summary of the several parametrics and non-parametric tests over here, right? So you can see this comparison of means, as I already mentioned, so if your data are normal, so then it is, so if your data are normal, then parametric is going to be applicable. And if your data is not normal, then non-parametric is going to be applicable. And you can see this, the normal parametric test is working on mean, and they are working on medians or mean rank. Clear? So we'll discuss about few of the tests today, right, with the live demonstration, right? So if your categories is two group, right, just like we have discussed about, right, gender, right, male and female, right? So this is two group. So we have to see this, the accessibility functions are normally distributed or not in the opinion of the respondent. If they are normally distributed, and if they have two groups, there are two conditions. If they are normally distributed, so first of all, the parametric is confirmed, but which parametric test needs to be confirmed? So we have to check the categories of the group, right? So there are two categories. So if two categories are there, and if the data are normal, we have to go for independent t-test, right? And if this is the same group and the data are not normal, we need to go for the non-parametric version of independent sample t-test. Independent sample t-test, that is Mann-Whitney U-test. Is it clear? Fine enough? right? So this is how we have to go for. Let's say there are three groups, right? So let's say in gender, if I'm adding third category, like prefer not to say. Now gender don't have two category, but they have three categories. Again, the same thing, the accessibility function, the data are not normally distributed and they are three groups, three independent groups. So instead of going with parametric, we have to go for non-parametric. But if the data are normally distributed, we have to go for one-way ANOVA. And if the data are not normally distributed, then we have to go for the non-parametric version of one-way ANOVA. That is called Kruskal-Wallis test. Clear to all of you? Please confirm.
Yes.
Yes, sir.
Yes, sir.
Right.
Yes, sir.
Right. Okay. Then we also have to see this. Let's say, we sometimes wants to check the effect of certain incident or certain scenario, right? Let's say if I'll talk about certain incident or certain scenario in terms of the COVID-19, right? So we want to check that, does COVID-19 affected, the performance of the students? So we might check the performance of 3 years before COVID-19 and 3 years after COVID-19. And then we have pre-COVID-19 and post-COVID-19 data, right? Although the scenario is same, the variable is same. The variable is the marks of students. But this variable has been divided into two categories or two scenario. That is before COVID-19 and after COVID-19. One more example on the same part, right? Although the variable should be one, let's say I want to check the performance of any sports person, let's say long jump, right? So if I want to check the performance of the particular sports person in Olympic for the long jump measurement, and before that I have taken some measurement of the 10 sports person before training, right? So I had gone through one test of them. So I had noted down their long jump size before going to training. Now, after comparing, the before training scenario, I had make them to go under the training part, and then we had the selection process. And then also I have, noted down 10 sports person selection process. So I have noted down their long jump size. So now I have two data. The variable is same, but the scenario is different. One scenario for the one variable is before training the long jump size and after training long jump size. And I want to check that does the training has made a significant impact on the performance of the sports person in terms of their long jump size, right? So if I want to check this particular data, so I have two types of data for the single variable, before training and after training. So I need to check the normality for both the kinds of data. And if the data turns to be normal, I need to go for paired sample t-test. I need to go for paired sample t-test. And if the data does not turns to be normal, I need to go for Wilcoxon sign rank test. Clear? Okay. Right. And right. So this is how we have to go for this kind of things. Clear? And the same way, if want to go for correlation for any of the data, whether you have two variables or more than two variables, so you can go for Pearson correlation coefficient if your data turns to be normal. And if your data does not turns to be normal, you have to go for Spearman correlation coefficient. Clear? And after correlation, we always check the regression. So which always measures the impact of certain parameters on certain things, right? So this is where if your data turns to be simple, parametric, that means normal. So you have to go for simple linear regression, and non-parametric version of regression is not that, because there are 17 to 18 types of regressions, which is applicable. Simple linear, binomial regression, logistic regression. So it depends upon the types of data that we have it. So it doesn't have any relation with the parametric and non-parametric in terms of normality. But yes, regression is a huge science. Those who are working on finance, economics,